Namaskar, I am Anand and you are watching Join for Education. Today I am going to answer the questions of electricity, subject science, class 10. Let's see the first question. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R by R dash each. This question has four options. Option A has 1 by 25, option B has 1 by 5, option C has 5 and option D has 25. Let's see the answer of the question. Resistance of a piece of wire is directly proportional to its length. If the piece of wire has a resistance R and the wire is cut into 5 equal parts, the resistance of each part equal to R by 5. Of that there is no problem to understand at this step. All the 5 parts are connected in parallel and equivalent resistance R dash is given as 1 by R dash equal to 1 by R by 5 plus 1 by R by 5 up to 5 times. The next step will be 1 by R dash equal to 5 by R plus 5 by R up to 5 times. 5 added 5 times, then we get 25 by R. Here R is the LCM. Then R dash equal to R by 25. Of that there is no problem to understand at this step. Therefore R dash by R equal to 25. So 25 is in option D. So the correct option of this question is D. Of that there is no problem to understand the explanation of the question number 1. Let's see the question number 2. This is the question number 2. Which of the following terms does not represent electrical power in a circuit? Option A, I square R. Option B, I R square. Option C, VI. Option D, V square by R. In this question, once again I read the question number 2. Which of the following term does not represent electrical power? So we recall the formula of power. We know that power equal to volt into ampere. So the option C is correct. According to Ohm's law, we know that V equal to IR. So we put the value of here. Now putting the value of V from 2 in 1, we get P equal to the value of V is IR into I equal to I square R. So the option A is correct. Now putting the value of I from 2 in 1, then we get power equal to V into V by R. Then we get here V into V equal to V square by R. So the option D is correct. Hence option B does not represent the electrical power in circuit. In this question asks us which of the following term does not represent electrical power. So option B, does not represent electrical power. So correct option of question number 2 will be B. Hope that there is no problem to understand the explanation of question number 2. Let's see the question number 3. This is the question number 3. An electric bulb is rated 220 watt and 100 watt. When it is operated on 110 volt, the power consumed will be option A 100 watt, option B 75 watt, option C 50 watt, option D 25 watt. Let's recall the formula: energy consumed by bulb P equal to V square by R. Therefore, R equal to, now by cross multiplication we get this step V square by P. From question it is clear that V equal to 220 watt and P equal to 100 watt. Now putting the value of V and P here, then we get R equal to 220 to the power 2 by 100. So 220 into 220 by 100, then we cancel out 0, then we get the square of 22. The square of 22 is 484 and the unit of resistance is ohm. The resistance of the bulb remains constant if the supply voltage is reduced to 110 volt. If the bulb is operated on 110 volt, then the energy consumed by it is given by the expression for power. We know that P equal to V square by R, and here V will be 110 to the power 2 and the value of R is 484. When we square this one, then a square of 11 is 121 and here 0 repeated 2 times. So a square of 110 will be 12100 by 484. Then this one is divided by 484, then we get 25 watt, and 25 watt is in option D. So the correct option of question number 3 is D. Hope that there is no problem to understand the explanation of question number 3. Let's see question number 4. Two conducting wires of the same material and of equal length and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combination would be. Let's see the answer of the question number 4. Heat produced in the circuit is inversely proportional to the resistance R. Let R and Rp be the equivalent resistance of the wire connected in series and parallel respectively. Let R be the resistance of each wire. So here will be, if the resistors and are connected in parallel, the net resistance is given by Rp denote parallel 1 by R plus 1 by R. So 1 by Rp equal to 2 by R. So Rp equal to R by 2. Hope that there is no problem to understand this explanation. If the resistors are connected in series, the net resistance is given by, we know that equivalent resistance equal to R plus R equal to 2R. Hence, for same potential difference V, the ratio of heat produced in the circuit is given by heat produced when resistors are connected in series, heat produced when resistors are connected in parallel. So here will be V square by Rs into T, V square by Rp into T. Here T cancelled out. V square cancelled out. Then we get Rp by Rs. So Rp equal to R by 2 and Rs equal to 2R. So here R cancelled out, then we get 1 by 4. Hence the ratio of heat produced in series and parallel combination is 1 by 4, and hence the option C is correct. So option C has 1 by 4. Of that there is no problem to understand the explanation of question number 4. Let's see question number 5. This is question number 5. How is voltmeter connected in the circuit to measure the potential difference between 2 points? Let's see the answer of this question, which is very easy. To measure the potential difference in a voltmeter should be connected in parallel. Of that there is no problem to understand the answer of question number 5. Let's see question number 6. A copper wire has diameter 0.5 millimeter and resistivity of 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Let's see the answer of this question. Resistance, suppose this is R of a copper wire of length L. Cross section A is given by expression R equal to rho, which is a constant, length of the conductor by area of cross-sectional area of the conductor, where rho is the resistivity of the copper. So 1 by 6 into 10 to the power minus 8 ohm meter. R equal to 10 m. Radius of wire is 0.5 by 2 millimeter, equal to 0.00025 meter. Now recall the cross-sectional area of the conductor, which is just like the circle. So A equal to pi r square. The value of A is 3.14 and the value of R is this one. After the proper calculation, we get cross-sectional area of the conductor is A, which is equal to 0.00000001965 meter square. So here will be length of the conductor equal to RA by rho. Now putting the value of R, value of A and value of resistivity. After the calculation we get this one 1.22.72 meter. If the diameter radius is double, the d radius will be 0.5 equal to 0.0005 meter. So the area here will be this one 0.0000075. Of that there is no problem to understand up to this step. So the new resistance will be R dash equal to resistivity into length of the conductor by cross-sectional area of the conductor. Now putting the value of each item and divided by this one, then we get 2.5 ohm. Now R dash by R equal to 2.5 by 10. After the calculation we get here 1 by 5. So R dash equal to 1 by 4R. As the new resistance will become 1 by 4 type of the original resistance. So I have answered 6 questions of the chapter electricity, subject science and class 10. Hope that this answer question will be useful to the students who are studying in class 10. If and together with the audience who are interested in physics. If anybody has problem or doubt to understand the explanation, write into the comment box. I shall try my level best to clear your doubt. My next video lecture will be related to the answer of rest question of this chapter. Till then, thanks to all of you. Thank you very much.